Good morning, class, and welcome to our video on fundamental counting principle. This idea is very closely tied to with what Mr. Eberhardt was teaching you about tree diagrams last time. So I have some of the same info up just to review. You should already have this down. Then we're going to add one more definition to our notes. So remember, we were referring to an outcome as a possible result of a probability experiment. So if you flip a coin, there's two possible outcomes, heads or tails. If you roll a dice, there's 6 possible outcomes, 1, 2, 3, 4, 5, or 6. Okay, so on and so forth. An event, the event is the experiment itself. So the thing that's happening when we're choosing something or something is happening randomly, that is the event. So if we flip a coin, that's an event. If we roll a dice, that's an event. If we spin a spinner, that's an event. If we choose an entree, that's an event, right? So it can be from choice or from randomly generating something. Okay. The sample space was all the possible outcomes that could happen, and you figured out how many events were in the sample space last time by creating a tree diagram. Well, today we're going to talk about how to do that using the fundamental counting principle. So, the fundamental counting principle says to find the total number of possible outcomes without a tree diagram, just take the number of outcomes for each event, and you ready for this? Multiply them. That's it. Some of you may have already noticed this pattern when you were doing your tree diagrams, but we're going to take a look at it specifically and figure out how to come up with the number of total possible outcomes without even having to draw it. Okay, so once you have that down, get ready to go on to the next slide. Okay, so here's an example of a tree diagram like the ones you were doing in the last lesson. And in this example, we're going to make two choices. We're going to choose either to get a sugar cone or a waffle cone. So there's two possibilities there. Or we're going to choose to get chocolate, vanilla, strawberry, or mint ice cream. So for each one of these choices, we have those 4 possibilities for ice cream. And if we look at the tree diagram, we see that we have a total of 1, 2, 3, 4, 5, 6, 7, 8 possibilities. Okay. The fundamental counting principle again tells us we can get that number without doing the tree diagram just by thinking how many possibilities do we have for cones? We have 2 options for cones. And how many possibilities do we have for ice cream? We have 4 possibilities for ice cream. So 2 times 4 is 8 total possibilities. Okay. If you think about why that multiplication works, think about how you learned multiplication in the first place. You probably learned multiplication as having a certain number of groups of the same size. So for instance, if you had 5 groups and each group had 3 things in them, you have 15 things total. Well, in this case, we have 2 groups because there's 2 possibilities for cones. We have 2 groups of 4 because each of these 4 kinds of ice cream work with each of these 2 types of cones. Okay, so 2 times 4 is 8. All right, we're going to do one together like this, and then you'll have a chance to do a couple on your own, where we're trying to figure it out without even drawing a tree diagram. So in this case, I'm going to spin the spinner, and I'm going to flip the coin. So for each one, I'm going to write down how many possible outcomes there are. So if I spin the spinner, there are 4 possible outcomes, 1, 2, 3, or 4. When I flip the coin, there are 2 possible outcomes, heads or tails. So all I need to do is do 4 times 2, gives me 8. Okay, if I were to do a tree diagram, that's either 8 possible outcomes for doing both of these things. And it doesn't matter, again, which order I do it in. I could flip the coin first and then spin the spinner. Like Mr. Eberhardt said yesterday, the order of these numbers doesn't matter. 2 times 4 is still 8. And because of that commutative property. All right, we're going to pause the video here really quick and see if you can do this one on your own. Then go ahead and hit play and see if we get the same answer. Okay, the answer you should have gotten in this one is 12. When you flip the coin, you get 2 possible outcomes, heads or tails. When you roll the dice, you get 6 possible outcomes, 1 through 6. So 2 times 6 is 12. All right, we're going to pause the video here once again to see if you can figure out the total number of outcomes if you pick one of these tiles, 1 through 5, and one of these colored circles. So how many different possible choices are there? All right, the answer you should have gotten on this one is 15. 5 tiles times 3 circles, 5 times 3 is 15. We're going to end with one that Mr. Eberhardt did in the last video. We're going to recreate the tree diagram he made. Let's see if you remember what our answer was, and make sure we can get the same thing using this process. So in this case, we're deciding everybody's going to do one appetizer, one main dish, and one dessert. So for the appetizer, we're choosing either soup or salad. For the main dish, I'm going to abbreviate. We could get either beef, chicken, or pasta. Okay, same for if I get the salad, I still get to choose either beef, chicken, or pasta. Okay, and then for dessert, each one of these is going to branch into two more possibilities. So I could choose either cake or pie for dessert. They're not quite as good on the tablet here. So bear with me. Hopefully these are legible. Okay, so this one here represents getting soup, then pasta, then cake. Okay, this probability here is getting salad, then chicken, then pie. Okay, so we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes, which you may remember is what you got when you did this in the last lesson. Okay, using our fundamental accounting principle, we're making 3 decisions. We're going to choose an appetizer that has 2 possibilities. We're going to choose a main dish that has 3 possibilities. And we're going to choose a dessert which has 2. So 2 times 3 times 2. I'll multiply all those together, gives me 12. Okay, we're going to end our video there. I'll give you a couple problems to practice using this fundamental accounting principle. As always, if you have any questions, make sure you contact your teacher between 10 and 12 or 1 and 3, and we'd be happy to help you out. Otherwise, I'll see you later. Bye.